On the next problem, we want to show multiplication with the rods. So the question that's asked is, what is 1/3 times 1/4 equal to? So my confusion was, when I watched the video, is why we were holding one specific one constant. I mean, it worked, but I guess watching the video I didn't understand. And so when I was looking at the rods, I thought of the problem this way. And it shouldn't matter which one of these two we think of as, I forget what you called in the video, but what we think of as more of the guy that's not the rod. And the reason it shouldn't matter is because multiplication is commutative. So I could rewrite this as 1/4 times 1/3, reverse the order, and that shouldn't be a problem. Of course, we know it's not. So let's go ahead with this guy right here and discuss how we're going to approach that. So again, we're going to create our rods. So that the unit rod is both nicely divisible into thirds and fourths. So these little green guys down here are fourths. Purple guys are the thirds. And so what we've done is we've constructed a unit rod there. Okay? Now, what we're going to do is, and the way that I want to think about it is, I have a third rod and I want to multiply it by a fourth, or basically take 1/4 of that third rod. So each of these purple ones are third rods. So this guy right here, that's equal to 1/3. But then what I want is, I want a fourth of this rod. So I want to split this guy up into fours, and I can do that very nicely. Okay, here's 1, 2, 3, and 4. So here's my 1/3 of the total rod, and I want to split that guy up into fourths. Okay, so I want 1/4 of that rod, which is just one of these guys right here. So I only want one of those guys, and notice that that's 1/12 of the total length of the full block. So this of the unit block. So this is equal to 1/12. What I think is more interesting is to try a problem that's a little bit different. Instead of 1/3, let's say it was 2/3. Okay. So now let's change this problem to 2/3 times a fourth. Well, if that's the case, I need 2/3, so 2 of these 3 length rods. Okay, so I'll take 2 of those guys. So 1 purple, 2 purple. This represents 2/3 of the total, right? So if I get rid of this guy right here now, because I'm working on a new problem, if I put 1 here, I guess I don't even have to do that. I already have them down there. Let go of that. Notice that I have, here's my unit, and I've got 1, 2, 3. So 2/3 of the full unit is 2 of these guys. Now I want 1/4 of this. So let's split this up into fourths, which I can do with this red block. Kind of cool. And so I want 1/4 of this 2/3. So I want one of these guys. And so one of those guys, if I put them all up here, notice that that is 6. There's 6 of these. So 1/4 of the 2/3 is one of these guys out of 6. So this is going to be equal to, let's see if they're right, equal to 1/6. And of course, we can do that with our algorithm, right? If we're taking 2 times 1, which would give us 2, 3 times 4, which would give us 12, and then reducing this to 1/6.